captures all my lectures that I deliver in a course, then will the college keep me for the job anymore? Why should they? So I create something to lose my job. Historical fact, way back in 1930s, the founder of our institute, Indian Statistical Institute, you know his name, Bimal, he thought that just by the look of a person, he could identify that, well, he is an Anglo-Indian, or a British Shahid, or a ordinary upper caste Hindu, or upper caste Hindu ordinary Muslims, so in addition to Hindus and Muslims, a little upper caste people, the lower caste people, and the tribals. He thought that if I take for a human being, there are several anthropometric measurements, like height, okay, like the width of the shoulder, like the length of all these fingers, like this circumference of this head, like the length of the chin. So he talked to the anthropology people and tried to understand what are the anthropometric measurements you can take on a human being. You could observe certain differences. Okay, so he was thinking of defining a distance between two persons. Now, the distance till then, what was known, we have learned in our high school geometry, is the Euclidean distance. So this means you have a point, x1, x2, xn, another point, y1 to yn. The distance is x1 minus y whole square, x2 minus y2 whole square, xn minus 1 whole square, and the square root. But then next he thought it doesn't make much sense. Because number one, it depends on the unit of measurement. But doing just Euclidean distance is not very fair. And so he thought we will standardize it. So how do you standardize? You subtract the mean and divide by the standard deviation. The standard way you do it. This means you just transform these variables, what you call standard variables. That means they will have the average to be 0 and their variation will be 1. So now all these attributes are comparable because they are pretty much in the same range. Number 2, when you do this Euclidean distance, x-axis, y-axis, just think of just a two-dimension, x and y-axis. And then these two axes are actually perpendicular. But had they not been perpendicular, will this Euclidean distance still work? The answer is very simple, no. If you say mathematics, something like some kind of orthogonal transformation on this data, and then the transformed data, they will be, the name of the variable will change, make a rotation of this entire data. In mathematical term, you multiply by what you call an orthogonal matrix, and so after this rotation or the multiplication of matrix, all these axes become perpendicular to each other. And now I can apply Euclidean distance. So he wanted to publish this paper. He sent to many journals. Everyone rejected. It's so fed up. We have an Asiatic Society in Kolkata. They used to have a quarterly bulletin. And now that paper is the most cited paper in the history of science. And it is called Mohalanovic distance. That came from a completely statistical consideration. But the problem came with actually the computational capabilities. So when the dimension increases, the volume of data increases, then this statistical formula, this is actually difficult to compute. In 1991, in ISI when I was teaching, I introduced them this concept of the notion of model fitting, maybe learning. Then I look into a very strong mathematics theory, very strong, by Kolmogorov, one of the top mathematicians of the world from Russia. So he said that if you have a function from n variables to one variable, so this means what he was trying to do, he was trying to look at many features Means I was trying to identify from these n variables or n features a conclusion that this is book. So this is a function from n variables to one variable. So then Kolmogorov proved the theorem that any n variable to one variable function can be written as a function of only one variables. Which you know, sin x is one variable function, x square is one variable function, e power x is one variable function, the sigma r is one variable function. So I saw the neural nets came. They are basically, if you just look in the structure, we see it as just a black box. No, black boxes. They are using Kolmogorov's basic principle. So you input n variables. There first it is getting to number of one variable functions. Then they are combined. Some one variable functions. So depending on what you call layers. So they are actually following this Kolmogorov's theorem, and we call layers and so on and so forth, but actually trying to bring down this association from n variable to one variable, no matter whether it's classification or you cluster, trying to do it. We are trying to understand that function or approximate this function with just one variable function and combining them. I call him, he is the father of machine learning basis, and these neural nets were developed from this one. Now this is what is not statistics. Statisticians will like to understand this data from some model or distribution point of view, make assumptions, and then try to make some conclusion. Okay? Fit your model on the 90% which you are left with, and then try to validate this thing on the 10% which are not used by this model. So this you go on doing over and over and over. Statistical learning is depending on certain model assumptions. So these two are the basic differences, and because machine learning, all these algorithms are going to be very iterative. Like the way I was teaching my son, very iterative. One day, next day I repeat, next day I repeat, next day I repeat, and I stop when my error is within certain limit. I stop when the son comes to machine learning algorithm, I have to say, first give me a proof that this is going to converge. So these issues are normally not addressed by, because we look at machine learning as a black box. Deep learning defines some four layers, it's not working, increase one more layer, 5 layer. So understanding Kolmogorov's theorem, his method, his notion of how many iterations are needed, how fast it converges, whether it converges or not, these have to be understood very clearly if you have to be a strong expert in machine learning. Okay, we cannot ignore statistics and mathematics to understand machine learning.